Welcome back to P4. Today we're looking at expanding binomials, and specifically we're looking at 1 plus x to the power n, and what we're going to do is we're going to use that to expand when n is fractional or it's a negative number. Now if you remember back to P2, we were expanding a plus bx to the power n, where n was a natural number. Now, when we have problems where essentially this value of a here is 1, or we can make it 1, it makes my expansion so much easier. And that is, as I was saying, where we're going to focus this video on. So let's have a look at both expansions. Now in P2, what you actually started off looking at is a plus b to the power n. And this was a to the power n plus, and if you remember using your NCR, and each time you're increasing your value, your power of a is decreasing and your power of b is increasing. And obviously that keeps on going until you get to just the power of b. And there we have it. And n is an element of our natural numbers. Okay, so that's what you looked at during P2 and how that applied then to what our a plus bx is, which is pretty much the same thing. And what we're going to be looking at is just the 1 plus x initially to the power n. And because we're using the number 1, it's actually going to make our life a little bit easier, but we're also going to show in a slightly different form just because we can then apply this to fractional and negative values of n. So we get 1 plus nx. Now these are just essentially these values, 1 to the power n, 1 to the power anything is just going to be 1. Then when I look at my next value, 1 to the power anything is just going to be 1, so it's not going to make much difference. And this time now we have b to the power 1, which is our x, and NCR, so if you got it as n, it's just going to be n here. Okay, now these values we're just going to do in the form of, if you remember, like nr, which is my NCR. This is n factorial over r factorial n minus r factorial. And this is the form that I'm going to be using as we go forward, just because it's a lot easier when we're looking at the negative numbers and the fractional numbers for our powers. So our next step then will be, the next one along will be n minus 1 over 2 factorial, and it's going to be multiplied by x squared. Next one along then would be n minus 1, n minus 2, and this is going to be over 3 factorial x cubed. Now, before I carry on and finish this expansion, a few people might be thinking they're a little bit confused about how this part in red, which I've got here, relates to these parts as we go forward. So I'll just do that very quickly next to it in black. If I pick a particular one, so say I pick this third one, okay, that means that r is essentially 3. That's what we're looking at, but we don't know what n is. So n factorial is n minus 1, n minus 2, n minus 3, and it's going to keep on going on forever. Yeah, because you're just taking one value away from n. On the bottom, r is 3 factorial, Then n minus r factorial means that I'm starting at n minus 3. Then I got n minus 4, then I'm times n minus 5, and so on. And what you can see is that from 3 onwards, they're all going to cancel. And that's why it just leaves me along the top n minus 1, n minus 2 over 3 factorial for that one. Okay, and the same process can apply to each one as we go through it. Okay, back to the expansion. Obviously, if I wanted to do a fourth one, n minus 1, n minus 2, n minus 3 over 4 factorial x to the power 4, and I can keep on going. What I'm going to do though is I'm just going to blank this one out, and what I'm doing is I'm just writing a more general version. Okay, and this isn't by all means the final version, we can keep on going. Okay, what you'll see is that for certain values of n for that power, my expansion actually could be infinite or it could be finite. It depends on the value of n. So in this case, we've got to prepare for if it is going to be an infinite one. And that is the expansion I'm going to be using. Now, to go with this expansion, there is a bit that makes it valid. And that is when the mod of x is less than 1. N is an element of the real numbers. What this essentially means is that your x is going to be between -1 and +1. Okay, and that's what we're looking at here. So if x isn't a value between 1 and -1, this expansion is not valid. So that's the algebraic bit that we are looking at. Let's have a look at some actual examples of how we actually do the expansion. Now, we've got expand 1 plus x to the power -4 up to and including the x cubed term. This is quite common because an expansion where it's negative or fractional will go on forever. So it's quite common to give us an end point, a definite ending point. So let's start by writing down what I'm doing, -4. Now, 1 to the power -4 is how I start. 1 to the power -4 is just 1, which is why it's nice. Then we've got nx for my second term. It says -4 times x. Now, my next term is n minus 1. So I'm taking 1 away, over 2 factorial x squared. And then my next term, n minus 1, n minus 2 over 3 factorial x cubed. And that's as far as I need to go there. Okay, so it's quite straightforward. It's just a matter of simplifying this now. I'm actually going to take an extra couple of steps, just hopefully just to show you, but you know, it's not too difficult here. But what I'm going to do is I'm just going to expand my factorials at the bottom just so that you can see them. Okay, now with these expanded ones at the bottom, you can see that as you do go through this, if you don't want to use your calculators, you can do some simplifying to make your life a lot easier. So now I can see that I've got 1 minus 4x, then I've got -2 times -5 is plus 10x squared, and that's over 1, so it doesn't change. -4 times -5 is 20. 20 times -1 is a -20x cubed, and it's over 1, so it doesn't change. And that there is now my expansion. Now, you don't need to do this middle line. I've just popped it in there just so you can see the cancellations. I actually often do these kind of straight from here. So I know 3 factorial is 3 times 2, so I'll just go that straight with the 6 there. And the 2 factorial is just 2, so I'll go straight in with that there. But I wanted to show you how I think about it and how it actually is. Now let's have a look at our second example. This time we get the cube root of 1 minus 3x. So 1 minus 3x as a power would be to the power 1/3. So although this is not a negative power, being a fractional power, it will go on forever as well. But the process is the same. So we're starting off with 1 to the power 1/3 is just going to be 1 plus, and then I've got n times my x. So this is n is going to be 1/3, and my x is actually going to be minus 3x. So it's always going to be this term and this sign. And then my next term is going to be n minus 1. So if I take 1 away from 1/3, I get negative 2/3. It's going to be over 2 factorial, and it's the minus 3x squared. And then I've got n minus 1, n minus 2, over 3 factorial, and then it is what would have been the x cubed. And now it's just a matter of simplifying and sorting out what I've got. So starting with 1, and then I've got 1/3 times negative 3x. So we can look in here, which is just going to give me negative 1x. Next, we can see we've got 1/3 times a negative 2/3. That's going to give me negative 2/9. Negative 2/9 divided by 2 is negative 1/9. And then when I multiply here, remember the squared. So minus 3 squared is 9, and a 9th times 9 is going to be just 1. So we've got a negative number times a positive number. It's going to be a negative number. So we've got minus x squared. Obviously, if you're in doubt, just use your calculator. Make sure you don't make any mistakes with this. And final answer being negative 5/3 x cubed there. And there we have it, all the way up to x cubed. Okay, so you just need to go as far as you need to. Now, you sometimes do get a question where they might ask you just for the x cubed one, which will mean you won't have to do the full expansion, just this section of it. And here's a nice example. So with this one, we've actually got 2 functions here. So the first thing I want to do is rewrite this as 2 plus x brackets 1 plus 5x to the power 1/2. And what I want to think about is that, well, this is going to give me an expansion of a lot of terms, and this is obviously just quite fixed. And for me to get an x squared term, it's going to be 2 times an x squared, and the x times an x. So that's what I'm going to focus on. Now, just before I get started, just noticed that I was missing the negative value there. It's very easy to make these mistakes. You do need to double check just before you get started, because obviously this was on the bottom, so it's going to be a negative power. So forget what I was saying initially about the positive power, it's a negative power there. But everything else will hold true. So let's look at first finding our x term of our 1 plus 5x to the power negative 1/2. So the x term is going to be nx, so this is minus 1/2 multiplied by my x, which is 5x, so it's going to be negative 5 over 2x. And my x squared term of this expansion is actually going to be the next term along. So it's going to be n minus 1 over 2 factorial, and then that's multiplied by 5x squared. So n times n minus 1, so a half, or negative a half times negative 3 over 2 is going to be positive 3 over 4. Divided by 2 is going to give me 3 over 8. 3/8 multiplied by my 5 squared, so 3/8 multiplied by 25 is going to give me 75. So 75 over 8x squared. Now, when I look at the expansion, so we've got 2 plus x, 1 plus 5x to the minus a half, and we only actually want the x squared term, so that's going to be when we have two lots of 75 over 8x squared plus x lots of minus 5 over 2x. And that's what we're taking, because we don't want to do a full expansion just for some simple terms. So we get 75 over 4x squared minus 5 over 2x squared. And jump into my calculator there, it gives me 65 over 4x squared. And that is then the x squared term. And this is quite a particular skill, an important skill that you need to learn, okay? Where you can jump into just whatever term you need, x squared, x cubed, and if you've got another bracket multiplied by it, you have to think, well, if you, in this case, we wanted an x squared term, there's two ways in which we can make it from this bracket. Okay, if you wanted an x cubed term, it would be the same. Yeah, 2 times an x cubed and x times the x squared term. And that's what you need to think about. Sometimes we're also asked, I have did this question, but sometimes we're also asked about the range of values of x for which this expansion is valid. And to do that, we look at the expansion and we look at this bit here. So we have 5x goes in our modulus sign, and then that is less than 1. We can divide by 5, and that is how we write it. It means that x must be between a fifth and negative a fifth. Okay, but we don't need to worry about that. The form in which we write it is just with the modulus sign. Okay, if you've got two expansions, you'd have two potential bits that are valid, and you'd have to go with the one that works for both expansions. But in this case, while we've got two brackets, only one of them is a series expansion. Now I'm going to give you a couple to try, and as always, I'll put the answers at the end of the video. Remember, it's rules of powers that are involved here. Top and bottom are the same thing. So this would be just like simplifying, say, y to the power of half over y, which is y to the negative half. Same kind of thing. Okay, so no real difference there. It's just a kind of way of almost getting you caught out. So this one we first need to write in this form, two brackets kind of multiplying by each other. Then we just need to look at the series expansion of the 1 plus 2x to the negative 3. And we're going to need the x squared term and the x cubed term. So x squared term of my 1 plus 2x to the minus 3. So the x squared term is n minus 1 to x squared, and that's over 2 factorial. So that's going to give me 24x squared. Now I also need the x cubed term. And that's going to be n minus 1, n minus 2 over 3 factorial to x cubed. So we've got, so 3's cancel, 2 will cancel, I mean 2 5's 10, 10 times 8, 80, x cubed, negative times a negative times a negative, so this is going to give me a negative 80 cubed. Now my x cubed term of 3 minus x over 1 plus 2x cubed, that's going to be 3 times my minus 80x cubed plus minus x times 24x squared. And that gives me negative 240x cubed minus 24x cubed. So that's minus 264x cubed. It doesn't say within this question, but in terms of when it's valid, 2x less than 1, so mod x less than 1/2. So both of these are series expansions. And we're going to want the x squared term. So what I'm going to do with this type of question is I'm going to do just the initial expansions for each of them. So this is going to give me 1 plus, and we get a half times minus x plus a half minus a half minus x squared over 2 factorial. So that is 1 minus a half x minus 1/8 x squared. Next, I'm going to look at the 1 minus 2x to the minus 1. And that is going to give me 1. Plus, so we get minus 1 times minus 2x plus minus 1 times minus 2 times minus 2x squared over 2 factorial. So this is 1 plus 2x plus 4x squared. Now, to find the x squared term, what I need to do is I need to look at both of these two expansions. So I'll just pop a red box around them both. and all the combinations where I can get an x squared by multiplying them together. So looking from the first box, we'd have 1 times my 4x squared. We've got minus a half x times the 2x. And we've got minus 1/8 x squared times the 1. So those are the combinations. So we get, if I think about this here, we get 4x squared minus x squared minus 1/8 x squared. And that will give me 23/8x squared. And that is the x squared term. Okay, now in terms of where is this valid? Well, if I look at my two series, one series is minus x is less than 1, which means that x is less than 1. My other series is minus 2x is less than 1, which is 2x less than 1, which is x less than a half. Now, one series is between 1 and minus 1, the other one is between a half and minus half, and it's this one, the half and minus half. That's what's valid for both series. So x is less than a half. Hopefully found this useful. Any questions, just pop them in the comments down below. See you next time.